Distinguished guests, please be seated as now we will invite the panelists to start the second panel. Semiconductors in motion, navigating strategic shifts in the global landscape. Let's welcome Mr. Terry Cao, Global Chief Marketing Officer and President of SEMI Taiwan as the moderator. Joining us are Mr. Mark Haink, financial journalist and technology columnist, author of Focus, The ASML Way, Mr. Yashinoko Ota, professor of Hokkaido University, the author of 2030 Semiconductor Geopolitics, and Dr. Philip Wang, professor of electrical engineering at Stanford University, and one of the contributors to Silicon Triangle. Please join me in welcoming them in a round of applause. President, the floor is yours.
Okay, good afternoon, ladies and gentlemen, and all the distinguished panelists. Actually, this is really my great pleasure to be here to moderate this session. I think, as you know that, there's no better occasion to talk about this topic at this big mega event, Semicon Taiwan Week. First of all, I want to thank the support from the MOFA, and also the organize my partner with the CIER and the DSAT. I think the reason why is I always talk about in semiconductor industry, we have lots of the challenge, like talent shortage, sustainability, supply chain, actually geopolitical actually impact the most. In the morning session over the other exhibition hall this morning, actually, I think lots of the speakers talk about the most of the challenge for the semiconductor industry is uncertainty. And the uncertainty is come from the policy and the nationalism competition. So today, I think this is a very great occasion. We have the speaker from around the world, Europe, Japan, Philip, you can do the both hand, right? Either Taiwan perspective or the US perspective. We should talk about how we navigate the supply chain resilience and the strategic realignment. Yeah, I think three of them are very well known. I think Philip is very well known in his professional technology research and also in the Stanford University. And also the Ota-san, he also published a book, especially the semiconductor geopolitics. Yeah. Last but among the list, I think Mark, this is the week you like promote your book, right? the very ASML story, I think is very interesting. So the first question I want to check three of you. Maybe not everyone here to know about the story, the research you are writing, or I think Philip also you are helping the Silicon Triangle that had the book. So maybe we can have each of your panelists to give us some summary. What is your key research or the essence of the book? What's the key message you try to deliver? So I would like to begin from my right-hand side. So, Mark, can you to begin with?
Of course. Is it working? Yeah, there we are. Thank you very much. Thanks, Terry. Yeah, I love technology. Well, just imagine that ASML was crazy enough to let a stupid reporter like me inside their company for about 3 years and describing how they were, experiencing the chip shortage and all the geopolitical pressure, and letting me talk to their leadership for a very long time and in intensive interviews, about 300 interviews I did. I traveled around the world, visited their customers and suppliers to get a sense of this company that is actually providing the most complex tool, the lithography machine, the EUV machine, the rest of the world needs. And during my research, I got the opportunity to talk to a lot of policymakers as well. And for me as a reporter, it was kind of an eye-opener that even in DC, they were willing to talk about this very crucial technology with a guy from the Netherlands. And it's not because of me, but because the company is so crucial to the rest of the semiconductor industry. And you might expect that ASML was a well-known company in the Netherlands because it's like a national champion, but it actually was quite obscure until a couple of years ago, because nobody realized how big this player was for the rest of the semiconductor industry. And the reason is we don't have any fabs in the Netherlands. So this company started growing and growing, getting pretty big for a Dutch size, because the Netherlands is just a small country. And in the meantime, of course, there's a lot of attention from the US side for this technology they're creating. And one of the reasons that ASML got to this huge market share, because it's a monopolist in EUV, quasi-monopolist in DUV, is that their supply chain is completely different than their competitors. So they started out with nothing. They had a very rough start. They were kicked out of Philips with a tool that nobody wanted and a technology that nobody actually believed in. There were just 40 engineers. But their CTO, who recently stepped down, was employee number 0. He found a roadmap that was an opportunity, and he was forced to find their suppliers outside of the company. One of their biggest partners, of course, is Zeiss, the German company. And together, they built this supply chain, this ecosystem of over 800 suppliers that provide like 80% of the value of this litho tool. And I think the latest version, if you were to buy one, Terry, it's 400 million euros. So, no, you didn't bring the cash? Okay. So 80% of the value of these machines is created outside of ASML, which makes these ties and bands of trust, bond of trust, as I call them, within the supply chain, very important. And also, it created a competitor in the litho market that was more agile than, for example, Nikon or Canon. And ASML kept its research budgets onto the same level, even during downturns. And it was possible to like spread the pain, the economic, financial pain, to the rest of its supply chain. And that way it got to this level of being a huge player and having all the research money to invest in newer generations. And that's the way they got to EUV. They were the only one who got EUV to this industrial level that you can commercialize it. And of course, EUV was an invention that was researched in Japan, and it was researched in the US and in the Netherlands. But it took a huge effort, 15 years, $15 billion of research, and a lot of focus by this guy called Martin van den Brink. He's like the Steve Jobs of the litho industry. And he's also the protagonist in the book I wrote. And for ASML, it was a huge gamble to let me into their company, but they wanted to be less obscure because they became part of the focus of the international attention as well. So they wanted to get an objective story out. What's behind this company? What's behind our philosophy? What's behind our strategy? And I know there's a lot of emphasis on the technology, on the nanometer side, but I was personally impressed by their strategic thinking, how they're investing, taking shares in company, taking over companies, and they're looking ahead like 10 to 15 years, which is another thing you often see in politics, because there's a lot of short-term vision as well. So these worlds collide in focus. Short-term vision of politics and the long-term vision of the semiconductor industry.
Thank you. Thank you for your sharing.
The button.
Sorry. Yeah. Yeah. So, Oda-san, can you also share with us about your book?
Yes.
What is the key essence you want to?
Okay. Let me introduce myself a bit.
Sure.
Even though my current title is a professor at Hokkaido University, but I've been a journalist for 40 years, and I posted to Washington, D.C., and Frankfurt in Germany, and most recently in Singapore. But I was not expert on semiconductors. I'm just a journalist to cover the international affairs, particularly international trade and the diplomatic policy and stuff like that. But when I was in Singapore and observing what's going on between China and the US and Japan, I found that Singapore is sitting in a very unique position in the globe because it's independent, very small, so that it's not. So to look at the major companies like such as China, Japan, and US, I thought I can observe them objectively. So then I found the semiconductor is very unique. Within in such a small tips, there's a world. So we can talk about the politics and the economy and the company management and everything in this tip. So I found, oh, this is interesting. So I started learning more about the technology and started interviewing the people in the industry and the policymakers. So that makes me to write a book. Then in that book, I started writing how the U.S. semiconductor policy was devised and developed in White House under the Biden administration and how the U.S. sanction worked on Huawei. And I was lucky to have a chance to interview the Huawei management level person, and I found how their reaction was developed in Huawei side. And it is a really tough company. It's very skilled, well managed, and they have technology, and they know how to use technology strategically. And it was a very interesting story. So if we have a chance, please take a look at the chapter. And also, I tried to compare the U.S. policy and EU's and the Chinese, and in which I try to figure out how the Chinese industry policy is developed and their technology policy. And using the example of Huawei and the memory companies. And I found it's very interesting. The Chinese unique way of promoting industry is to give money from the government as a beginning to everybody, right? So then there's a competition among the Chinese companies domestically. And eventually there will be a winner and loser. Then like a rolling snowballs, as the money comes to the winners, even from abroad. So that's a way how to foster the competitive policy in China. And eventually the loser will disappear from the market. And the winner will spill over to the global market after the experience of success in Chinese market. So I thought this is really interesting and also very strong. It's very difficult to compete with those policy-wise and the company management. That's one thing I learned through my investigation in the book. And finally, I wrote a bit about the future of the industry. Because when I wrote the book, and it was just before TSMC decided to come to Kumamoto. So, and there was a discussion in Japan that Japan has experienced a peak period of time in 80s. Japanese chips dominated more than 50% of the market in 80s, but now less than 10%. So the people worried about the future. So the 10%, 5%, it will be 0% in year of 10 years and for the time. So then, what is the key element to revive the Japanese government, Japanese industry, is technology first. So you have to have technology, definitely. And you have to have the talent, the people. And also we have to have the vision of the future, how to use semiconductors. That's the most important part. Because we are going into the stage of the AI chips. The AI chip is a major player in the chip industry. But the question is how to use AI for what? So you have to have the vision first. Then you can design the AI chips. Then you can produce. So in a sense, I use Amazon Alexa home because I live alone. So I want to have somebody to speak with. So when I come home, I said, I'm home, Alexa. And she says, well, welcome back, Yasu. I'm glad you addressed me such like that. And in the morning, I asked her the news and the weather and everything. So anyways, I feel like Alexa's here in this box, right? But this is just box speaker. So it was, where's Alexa? It should be somewhere in data center, in California maybe, or in Japan. So there's data center there. And in the data center buildings, there's a server room, of course. The rooms, like you see the espionage film, like, security and breaking the doors. That's server room. Then inside the room, there's servers, bunch of servers. And inside the servers, there's a board made by probably NVIDIA. And on the board, there's the chips. And in the chips, it's on a chiplet, there's a GPU and a memory. So, I'm sorry. So what I was trying to say was AI lives in the chips. So that is something I wanted to write in the book when I stop in here.
I think definitely AI is the new driver for the semiconductor, and also AI can also help the semiconductor to be more smart in terms of the manufacturing. So let's shift to Philip to share with us some of your views. Thank you.
Yeah, sure. I'm Philip Wong. I'm not a journalist. I'm just a technologist, and so I come to Semicon Taiwan for the technology part of it. Maybe 3-4 years ago, there was a project from the Hoover Institution at Stanford in collaboration with the Asia Society in the U.S. The project is the title of the project is the United States, Taiwan, China, and Global Semiconductor Security. That was kind of like the time when the U.S. government suddenly realized that semiconductor chips is a part of national security, and they wanted to understand a little bit about where semiconductor is going and how it intersects with national security. Because for many years, the U.S. government, for example, in the Department of Defense, they did not believe that semiconductor is part of the national security consideration, because they believe that chips can be bought everywhere. It's a globalized technology, that any advances in semiconductors would not lead to any asymmetric advantage in terms of military advantage from the U.S. So therefore, they just say, well, there's no need to pay attention to that. We just buy the chips, and everybody can buy the chips, and there's no need to be the leader on the chip. But what they did not know is that this is a foundational technology for a lot of the advanced technology that we want to have, including any new military technology, drones, AI, quantum, 5G, 6G. They all depends on chips, as the previous speakers mentioned. So it's really strategically important to all countries. And also concomitant with that, after decades of neglect from the U.S. government, there is a loss. The industrial base for semiconductor manufacturing has gone away from the U.S. And as a result of the loss of industrial base, they also are at the verge of losing technology leadership, and as we see today. So the study was to try to understand the role of semiconductors in this world, and also to understand how national security and semiconductors are intertwined together, especially about China and Taiwan. As you know, there's differences in opinion about the politics in China, mainland China, and also in Taiwan. So this is a study that led to a book which is called the Silicon Triangle, in which I contributed mostly the technical part of it. I'm not a political scientist, nor economist, or a policy person. But the one thing, the few things that came to you asked Terry, you asked about the conclusion of the book, right? The main conclusion is really is that the technology itself is not a static technology, because a lot of the politicians think of it things like chips, maybe think of it as a static thing. Well, I have a technology, I have it now, today, and that's good enough for the next decade or so. But as you know, technology evolves, and it has to advance year after year. Otherwise, it loses its value, because nobody wants yesterday's chip, right? Everybody wants tomorrow's chip. And so this is one key conclusion that we brought to the table as we advertise our book to the Washington, D.C. This is one key thing that we keep telling the policymakers in Washington, D.C., that you should think of semiconductor technology as a technology that needs to constantly evolve, just like a shark needs to keep swimming. Otherwise, it doesn't work for the shark. So it's not like a commodity, like an oil. Oil's there in the ground for millions of years. You just need to take it up. But semiconductor needs to be constantly evolved and advanced. And so doing the R&D is terribly important. And so that's the message we gave them.
It's very essential in the semiconductor industry. Take the leadership in terms of technology. That's the only way we can survive. Yeah. So I think most of you, and also the book you publish, maybe some of the content is summarize the fact a couple of years ago. But I would like to raise the second question. I think under the current new dynamic, especially I think since last year, lots of the new politicians around the world become the new leadership. Yeah. So under that circumstance, what did you see the big difference, or even it's getting better or getting worse? Like how do you see such as the leader from? I think the leader from recently, so sorry, yesterday there's a new prime minister need to coming up from Japan, right? From US, there's a new leadership just elected this year. So what do you see this impact? You see this different to impact the semiconductor industry in your country or in Taiwan? Yeah. So maybe can I have the Otto-san to speak the first one to take the rotation? Yeah.
Well, Japan has experienced a very unstable period of time in the political arena. But one thing clear is very sharp and policy on a semiconductor, which is to produce domestically. So the TSMC came to Japan, Kumamoto, and started the production. And Rapidus was created, which is a government-backed company. It's technically speaking, it is a private company, but it is government-backed, more like a state-owned company. It's a national project. And this strategy just continues, no matter who is sitting in the Prime Minister's office. Okay. So I don't think...
any impact for the other country? For example, like a new leadership from U.S., does it impact the semiconductor strategy in Japan?
Well, yeah. Definitely. I think Mr. Trump is a big issue. Yeah. I'm sorry to say that.
Don't worry.
I think we have...
This is a country of the freedom, so don't worry about it.
Thank you very much. So then...
only a few people from U.S., as I know.
When actually last time I came to Taiwan, I was in a bus, and the tour guide says something about Mr. Trump. The one of the American citizen was in the bus and started talking. Mr. Trump is great, and don't blame him. They started to long speech. Yeah. So I have to be very careful when I speak about Trump. But one thing clear is Mr. Trump knows what America needs. It's production capacity inside the border of the U.S. And by the same token, Japan has the same problem. So when Mr. Trump goes his Trump's way, made in the American way, so Japan has to do the made in Japan way. So this is a competition between the government, even though they're allied nations, Japan, Netherlands, or EU, UK. So to count, the US power is overwhelmingly strong than others. Well, put China aside now. So then to counter the power of the US, I think Netherlands, Japan, and Korea, and Taiwan have to team up. So this is the issue now being discussed in Japan. But the answer is not clear because there's a political difficult issues between Korea and Japan, for example. So we have many issues we have to overcome. But the target is clear.
Yeah.
Team up.
Sure. Thank you. Philip, can you share with us about your observation? Especially you stay in US, you can more like a first-hand observation about what's the big difference about the impact. Yeah.
Yeah, indeed. I live in the U.S. I work in the U.S. and there has been a big impact since the new administration came on board this past February. There are three things that is important to know. I'm sure that you all know about it, but there are three things that are very important. One is on the implementation of the CHIPS and Science Act, both in the manufacturing subsidy and also in the R&D part of it. There's a great uncertainty with this new administration. In the manufacturing subsidy, it's unclear what they're going to do beyond what they have done with one of the biggest U.S. company just recently. And it seems that many of the contracts that are drawn up between the U.S. government and the major companies who are receiving those manufacturing subsidies are probably may be renegotiated in some point in time, and it's unclear what they would do. There's a great uncertainty. Second part of uncertainty is on the R&D part. Our friends from Europe just described that they built a bunch of pilot lines and supported many of the activities in Europe for the global innovators to come and use the pilot lines and develop technologies. On the other hand, on the U.S. side, they just canceled the NetCast, which is the nonprofit set up to run R&D for the CHIPS and Science Act. It's unclear what they're going to do going forward because any transition beyond that is going to be at least 6 to 9 months, if not more, before they can restart what's going on in the R&D side. The third thing that is probably has the biggest impact over the long term is the attack on the universities. I work in the universities. I see that every day. And so those will be a big impact going forward, both in terms of attracting international talents to the U.S., which has been the case for the last many, many decades, that the U.S. has been able to attract the best talents in the world to come. And many of them do stay. Statistics show that over 80% of the foreign students stay in the U.S. and build their careers there, at least initially. And so the U.S. is the net benefactor of all the global talent flow. And that is going to be severely hampered going forward. And second is the impact on the research universities and the funding of the universities, as well as the way the universities are being run, and thrown in a big turmoil right now, and everything is unclear. And especially for these kinds of things, the impact is going to be felt not just immediately, but also decades later, because for example, because of the uncertainty and the lack of funding, many universities will pull back greatly in terms of hiring faculty, broadly speaking. And those limitations or changes in the faculty hiring, the impact will not be felt immediately, but it will be felt decades later, because the careers of these faculty will be many, many decades long.
U.S. will be the beneficiary for all the new policy, right? But as you can also feel there's also some like an impact with some consequence, right? Yeah. Okay. Yeah. Good to know. Yeah, Mark. How about your observation?
Well, first of all, I totally agree with you, Philip, that research is, of course, the foundation of all innovation, and it's kind of odd to see that the US has so much emphasis on controlling and limiting the rest of the world, while it should also spend a lot of effort in promoting and helping its own research. So this is kind of counterintuitive, which is, I think, a long-term and a short-term vision difference. For me personally, it's very tiresome, all these developments, because I have to keep on updating every new version of the book. Yeah. And it's impossible to digest all the news that's happening. But let me just get back to the chaos and the diversity in news, because tariffs are now, export controls are part of tariff talks, as we just heard at the first panel, and which makes things even more unpredictable. And it creates chaos, for example, in the global economy, which kind of pauses investments in new technology, and in the end, that will hurt the entire semiconductor industry because there's less appetite for chips, unless, of course, they are AI chips. So the rest of the market is like pausing, waiting for this big leap to double in size to 1.2 trillion, I think is the latest figure, in 2030. So there's a lot of chaos in DC, and what I've experienced and heard back from the people working at BIS is that there used to be this very director role of the NSC, which is not a thing anymore. So the oversight of export control has kind of been drawn to the White House itself, and it's for a lot of people in DC, it's also they're wondering what's happening behind the walls. Sometimes it could be H20, not getting a license for export, and then the other week it's the other way around. What I do see is, looking back in history, there was this point that I remember President Trump in his first term back in 2020, he considered getting Huawei off the entity list while doing to get a better trade deal with China. So he brings back this aspect of economic, a way of thinking instead of the usual national security argument. And I do acknowledge the risks in national security, but if you zoom out of this political framing, then you see that there's a need for this industry to deglobalize, because in 20 and 21, when the chip shortage hit, that's also the reason why I started my first chapter there, because that was the point in time that politicians started to realize, hey, we're depending on this technology. Chips are in every device, not only in our military devices, but also any tool you use in your daily life. And they're also going to be in the humanoids. They're going to take care after you when you're old, and there are no human hands available. So we have to make sure we have domestic alternatives to this a small area of the planet that produces practically all the chips in the world. So actually my point is the semiconductor industry is like grown too successful to be depending on just a small fraction of the planet. So it makes sense economically and also for society to start duplicating elements of the industry, even though that's counterintuitive, because this semiconductor industry has been it's based on efficiency and on concentration. That's what driving innovation. So it probably slowed down the pace of innovation. Yet, the profit is that we get more reliable supply chains, and COVID has taught us a lot, I guess.
Yeah, I think I fully agree with you, especially lots of the country, because of the national security, economic security, or digital sovereignty. So lots of debate about it's either efficiency or the security. or just in time to just in case, or friendshoring to onshoring. Last but not least is incentive with the tariff or sanction. I think lots of the uncertainty or lots of the clarity. We need more industry or some the different stakeholders to join together to find out what is the best balance for managed industry as well as the entire geopolitical uncertainty. So last question I would like to have your input is about, like we mentioned, lots of the new impact to our industry. What do you observe, any kind of example for the further collaboration, either private public partnership model or the cross country or the cross regional alliances? Any kind of the example you already see happening now, or you foresee there should be, or how it works? So can I have Mark to begin with?
Okay, so let's get back to the Netherlands. Very small country, building a huge chip machine that the whole world needs. But in Europe, ASML, the country of the Netherlands, has to decide about ASML export controls themselves. So it's not Europe calling the shots over any restrictions or licenses they need, it's the Netherlands themselves. And this is kind of a hard bargain because if you look at the economic size of the US compared to the Netherlands, I think it's 20 times bigger. So it's not a good negotiation position. So what the Netherlands is trying to achieve is getting back to the multilateral agreements like the Wassenaar Agreement, which is hard because there's a war in Ukraine, of course. And on the other end, you see coalition attempts that started out in the Netherlands and is now containing, I think, about 8 or 9 EU countries that are also involved in semiconductor manufacturing or supplying to the semiconductor industry, which is countries like Germany, which has Zeiss and Trumpf. They're important suppliers to ASML. And of course, Belgium with IMEC. We heard about IMEC in the first panel. And also France, which happens to have great AI companies, as I just heard, like Mistral. Okay, well, I'll have a look. And so together, these companies, they're trying to promote the EU as a new era for companies like TSMC to expand or global foundries. Unfortunately, Intel paused its, well, actually scrapped its plan to expand in Magdeburg. So there's room for another highly advanced fab in Europe, because I think in the end we will need even these highly advanced chips in Europe too. What you see happening is that the coalition, starting out in Europe, is reaching out to other areas of the globe. So, for example, Southeast Asia is very interesting. Countries like Malaysia and Singapore, now we talked about that, they're interesting because they're like somehow a neutral area within these superpowers. And you see even ASML's supply chain is already expanding in Malaysia because they want to be able to service and to supply ASML, but also Applied Materials, KLA, you name them, who are also customers of their ingredients. They're moving to Malaysia because this industry is following wherever the fabs go. They're following wherever the huge ecosystems are, whether it's TSMC here in Taiwan or the Japanese expansions or in Dresden in Germany, China mainland, of course, Singapore, and the US. It makes sense for this industry to spread out over the globe.
Yeah, thank you. So, Philip, may I have read the second one? Thank you.
Okay. Maybe I'll make some comments about something that I do know a little bit about, which is how changes in technology may change the kind of policy that we want to make for semiconductors. First of all, technology evolved, as I mentioned earlier. And today, if you go to Semicon across the street in here, you see that semiconductor technology is really at a crossroads. And two-dimensional miniaturization is no longer the main driver for technology advancement. So the companies who has been successful in miniaturization may not be the same company who will be successful in the next few decades. Right. So there are new things coming in on board, new materials, new devices, 3D stacking, advanced packaging, chipless, all these new technologies. Whoever can figure out advances in these fields and make a good business out of it will be the leader in the next few decades. Right. So companies who have been leaders in shrinking devices and very successful in doing that may not be successful in the coming decades. So that's one. Second is that we already, for the last few decades, since the invention of the promotion of the fabless foundry model, which really created a whole industry of fabless companies. This ecosystem is also emerging because you can see that fabless companies are getting closer and closer to the manufacturers to co-optimize, co-design their chips and their products, their applications. And so they're getting closer and closer together. So a high degree of trust is required for these kinds of collaboration. Because you have to share your roadmap, you have to share your technology plan, you have to share your product plan, and a high degree of trust is needed. So that's very important quality. And the other one is that because the design of the whole chip and the whole system as a result depends critically on the device technology itself. So the advantage or the controlling, the party who controls technology has gradually moved from the designers to the chip company, to the chip manufacturers. If the chip manufacturer used to be just somebody who just run the chips and then you sell the wafers to the system company, but not anymore. So that's also very important to figure out. Going back to this question about trust, a lot of people think, okay, maybe we have to globalize. We are kind of splitting into two different worlds. One is the kind of like-minded country, Western world, and then there's China, and whether China will become a semiconductor powerhouse as you see in the Western world it is today. I think what a great part of it depends on one very critical element that I mentioned just before, which is trust. And without the trust, you will not have a strong semiconductor industry.
Yeah, inspiring. And also, I also observed that, especially in the new product coming up, for example, the AI chip, actually also create a new collaboration model between the company or even between the region or the country, right? Like a couple of years ago, maybe few memory company from Korea will join Semicon Taiwan, but because the new AI product, you need to open your arm to embrace based on the new collaboration model with the new product. So I think you really make the very good example about the industry, how to moving forward, yeah? So last but not least, Wada-san, can you share with us? Thank you.
I think we will see more on the competition heavier and heavier.
Yeah.
But how to look at the competition, meaning of competition is going to be very different, I think. I think competition will play out across 4 dimensions. One is nation, between nation and nation, of course, China and the US, or US, Japan, whatever. Then between company and companies, right? Naturally, they are competing each other. But the company itself has to compete with the government of its own. And the company has to compete with the foreign government. So the 4th dimension is going to be very difficult, complex the equation to find a solution with. So we have to find the point of balance somewhere in tug of war game, the pulling the rope from both sides. And it seems to me the PowerPoint is leaning heavily on the government side now, right? But there is a strategy that the company can play with. For example, I was trying to figure out how the NVIDIA's chip is made, and the chip is designed by NVIDIA and manufactured by TSMC, and to make the chip functional, you have to have the SK Hynix memory, just besides the GPU. Then I asked, the more the NVIDIA sells their product, the more the SK Hynix gain the profit. Yeah. So I asked my SK Hynix, why you can invent such a memory? Yeah. Why not Samsung? And the friend says, thanks to Japan. So we been successful to invest, making this HBM with the help of two Japanese companies. One is a machine company and one is a material company. So that means even though the nations competing each other, the company has to employ the strategy to align with, it's cross-border thing. So again, it's about trust. Trust has to be necessary from the government, but also you have to develop your own trust with your partners somewhere in the globe.
Through the same situation about the trust and also cross-company, cross-country. You want to make some final comment?
I just wanted to add on that bond of trust that you also see a lot of single sourcing and dependencies in the industry. That's with at TSMC, where there are just a couple of tool makers that can provide these tools, and these are like very brittle but a valuable chain. Mm. And the funny thing I recalled from meeting all these people in the industry that it's not a lot of people. It's like a network of people who have worked in this industry for decades and go back long time. Well, just look at Morris Chang, of course. He's in the industry for 93 years. And, well, he's 93 years, but seems to have been in the industry for his whole life. And you see the same thing at ASML. These old, usually men, that really have this network. And it feels odd that it's now being torn apart by, well, new politics and new economical laws.
Yeah. Thank you for your sharing and your comment. Yeah, I think this almost conclude, and because the time limitation to the final wrap up, I think first of all, thank you for all your input. I think your point resonate me a lot. I think. It also inspire a lot, and lots of the example you made. Actually, we have some commonality and reach some consensus. But I overheard to keep listen to some of the keyword like trust, right? And also, for example, the how to build up the partnership by the collective model. So I feel like for the industry moving forward. Especially how to manage the geopolitical uncertainty, or how you make the good balance of the resilience. I think definitely we need trust and transparent the global platform. We have to be also worked by the public and the private partnership. I think Ota-san, you also talk about even sometimes not every company is try to fully align with the government, or there's sometimes there's a lot of the conflict of the interest or dealing with a different government. But how we build a platform we can conversation either with the multi-government or the multi-industry, so that we can create the best of the policy which can really benefit the entire semiconductor industry. Ultimately, we can benefit all the human beings' life. I think that's nothing more important than that. We should have the conversation continue to moving forward. So once again, I want to thank every participant today and all the great work support from the MOFA, the GSAT and also from CIER. Yeah, thank you very much. Thank you.
Thank you all for all the valuable comments.